In this lecture, we will learn about calculating critical numbers. A critical number is a function f of a number such that either the function's derivative is 0 or the f prime c does not exist. Find the critical numbers of the function x cubed plus x squared plus x. So in the first step, we want to find the derivative of the function and equate it to 0. So the derivative of the function is 3x squared plus 2x plus 1 equal to 0. Now that we found the derivative and equate to 0, we try to factor. But factoring is not quite easy here because you have the irrational root. So let's do the negative b plus or minus square root b squared minus 4ac formula divided by 2a. So it's negative 2 plus or minus square root b squared is 4 minus 4ac. A times 3 times 1 divided by 2 times a, 2 times 3. Simplify further, you have minus 2 plus or minus square root negative 8 divided by 2 times 3, which is 6. So the critical point definition says that the function's derivative is 0 or the function should not exist. In this case, the value of c, the function derivative is 0 or the function should not exist. We did not get a chance that the function is 0, neither we get a chance that the function does not exist. So you can say that there is no critical point in this case. Similarly, let's do one more example. F of x is 3x minus 4. So for this example, first you want to know the definition of x. Absolute x is x or negative x. X for x greater than or equal to 0, negative x if x less than 0. Having known this, let's try to calculate the functional value f of x. So the definition says either it's 3x minus 4, where 3x minus 4 is greater than or equal to 0, or negative of 3x minus 4, where 3x minus 4 is less than 0. Having known this, let us simplify one more step. So you have f of x equal to 3x minus 4 for x greater than or equal to 4/3, and for x less than 4/3 you have negative 3x plus 4. So now find the derivative. F prime x is either 3 for x greater than or equal to 4/3, or it can be negative 3 for x less than 4/3. So at 4/3 we have the derivative jumping from negative 3 to positive 3. So we have some point where the derivative is not exists. So we say x equal to 4/3 is a critical point. Here in the previous example, you might want to specify that you are saying no critical point because you have negative of a root, which means it is root 8, and the negative inside the root will give you an imaginary number. So this cannot be imaginary, hence you say no critical point. In the next example, the closed interval method, you want to find the max or the min values for the given function using the closed interval method. So in the first step, you want to find the values of the function, the critical numbers of f in AV. Then you want to find the values of f at the endpoints in the AV. Then the largest of the step 1 and the 2 is the absolute maximum value, and the smallest is the absolute minimum value. You want to make a note here before the first step that when you find the critical numbers, you want to do this df over dx equal to 0, or you want to find the horizontal tangent. So let's do this example. Use the graph to state the absolute max or the min and the local max or the min of the function. So let's do this. Let's read the graph carefully and let's say all these values here. We have a horizontal tangent, again a horizontal tangent, and we have a sharp point here, and these are the endpoints. So you can also mark the points here. It's 2, 3, 4, 5, 6, 7. So you want to write the critical numbers here. Say that the critical numbers are the points x equal to 0. So at 0 you have a horizontal line, which means the slope is 0 or f prime is 0. That's the definition of critical number. At 1, at 3, at 5, at 6. At 6 you have the derivative not existing, you have a sharp point, and at 4. So wherever you see the definition of the slope equal to 0, or you see that f prime does not exist, the sharp points, all these points are called as the critical numbers. Then you want to calculate absolute max equal to 5 at x equal to 7. Then read the graph carefully. Absolute min 0 at x equal to 1. So this is also called as the global max and the global min. Now you want to read the local max and the local min. For the local max, you move on to each small interval and you read the maximum and the minimum value. So you have the maximum value at 2, 4, and at 3. Local min, you have minimum value at 0, then 2, then and at 1. The next example, you're asked to find the absolute max and the minimum values for the given function on the interval negative 2, 3. So we apply the closed interval method here. So in the step 1 of the method, we write down the given function x to the 4, negative 2x square positive 3. Then we have the derivative of the function, which is 4x cubed negative 4x. Then we have the derivative equal to 0. We equate it to 0. And we want to solve for x. So you calculate this. You see that 4x cubed negative 4x equal to 0. You're good to factor 4x from each of the term. You have x squared negative 1 equal to 0. So either 4x is 0 or x squared negative 1 is 0. But this can be factored further as x minus 1 times x plus 1 difference of square equal to 0. So either x is 1 or x is negative 1. So in the step 1, our work is to calculate the x values by making the derivative to 0 and solving for the equation. Then step 2, you want to draw a number line with all those points. 0, you did calculate x is negative 1, positive 1. Similarly, at least a few values, say x equal to 2, 3, and you have -2 here. So now read the values carefully. Functional value at -2, -1, 0, 1, and then 3. So functional value is 11, 2, 3, 2, 66. Now you start reading the absolute max and the minimum values. So your step 3 will be absolute max and the absolute min values. 66 is absolute max and 2 is the minimum value. The next example, for the function find the max and the minimum value on the interval 0, 5.